Hello, this is a little example of how shell scripting makes my life easier. There's a lot of cool CLI utilities that allow you to work with files, find data, make replacements, edit files, really, really anything that you can come up with. There's probably a CLI utility to do that. Here I made a small list of things that CLI utilities allow you to do, some of my favorite ones, but not nearly all of them. It is easiest to use them on Linux. It's the easiest to install them, but you can also use them on different systems. On Windows, you can use WSL, or there's virtual machines, there's Git Bash. On macOS, there's NixOS. You can install those as packages, but in Linux, that's the easiest, so that's what I have here. And in this example, I will show you I have Anki cards, and Anki is a program for flashcards. You can create and study flashcards with pretty much anything. Here I'm using that for Japanese. You can use that for any language or really anything, not necessarily a language. And here I have sentences, and I made it so that when I switch to the back side of it, also plays the audio like this.
友人に車で家まで送って
And here I don't have many cards. But if I had a lot of these cards, it would be a pain to create the audio for all of those files. There is Google Translate, and it's a pretty good source for translations in general. And one of the things that Google Translate can do for you is generate the audio. So here I have a list of sentences from Anki here. Let's take this sentence right here. Let's paste that in. And I can click on this speaker's icon to play it.
バスに間に合いませんでした。
Right? But there's not really an easy way to download that. So in the network tab, there's not an audio file that gets sent.
バスに
There's probably WebSockets or something. There's a whole lot of weird stuff going on here. So it's not easy. You could pay Google for their API and use that for your project. But I find that meaningless because first of all, you can use Google not only without paying them, you can also use that without an account. So here I'm not even logged in, and I can use this translate feature. I can get an audio. So Google Translate, by all means, is a publicly available service. So I wouldn't pay for that or sign up for that. But luckily, there is the project called Lingva, which can be hosted on any number of instances. So here I have one of the instances, that is lingva.ml. And what Lingva does is it forwards your requests to Google Translate. So I can use the same as Google Translate. And it gives me the same result as Google Translate, and it also gives me the audio right here. So,
バスにま
or also in English.
I couldn't make
And what's really neat about that is, first of all, it doesn't do all this weird stuff in the background in the network tab, but also here is the request I made. And that request, let's look at the response. So the response has page props, type, translation, pronunciation, and then audio. It has the audio in that. So it's really easy to replicate that request and extract the audio yourself. So I'm going to copy that request as curl, so as a command that makes that request. So I'm going to paste that command into VS Code right here. So this is the command. It uses curl to make an HTTPS request to Lingva, and it also makes it so that the request looks exactly the same as it's coming from the web browser, which is why it also has those headers. So it kind of spoofs the user agent, so it looks like it's coming from a real web browser and not from curl. But I don't need that. Lingva does not care about that. It does not filter your requests based on whether or not they're coming from a real browser, which is another cool thing about Lingva and free software in general. It doesn't try to lock you in into anything. So I can just leave that as that. I'll just leave the compressed flag because by default I think curl does not allow responses to be compressed. And I'll make that on the same line. So there it is. I can take this command and let's go to desktop, and I'll save that as a response.json. And I can, for example, use less to view the response. So here it is, same as in the browser. It has page props, which has the translation, So you can also use that for extracting translations, making a lot of translations. But I'm interested in the audio. So here's the audio. It has the audio for the query and for the translation. I'm interested in the query. So the audio is an array of numbers, and each number here is a byte. So I'll be converting that into bytes later on. But first of all, I need to extract that query from the whole JSON object. For that, I'll use the JQ program. JQ extracts data from a JSON file. So first of all, I'll cat out the response, and I'll pipe that into JQ. I can specify just the dot to print everything. It's also going to format that nicely and add color. But I need dot page props dot audio dot query, and here just gives me the array of numbers that is the audio. Next up, I'll need to convert those numbers, which are decimal numbers. I'll need to convert them into bytes, and I'll convert it into hexadecimal, and then I'll use XXD to convert the hexadecimal hex dump into the plain file. So to do that, I'll first remove the unnecessary characters, which are the spaces, the square brackets, and the commas, like that. I need the deflag. Okay, so here I don't have those characters anymore, but I also have empty lines. So in the beginning and in the end, I have those empty lines. I'll also remove them using grep, E for extended, and V for invert. So I'll remove the matched lines, and the lines I want to match for are that, which is the beginning of the line, followed immediately by the end of the line, which is another way of saying that it's an empty line. Do that. Now it doesn't have the empty line at the end and also at the beginning. Next, I'll pipe that into a while loop, while read decimal, do printf %d new line decimal done. So it prints out the same thing as before, except now it's using printf, and I can replace this %d with %x for hexadecimal, and that's almost what I need, except some numbers are only single-digit numbers. Well, I'll need all of them to be two-digit numbers. I'll need to pad them with leading zeros, so I'll need to pad them with zeros, and I need them to be 2 characters wide, every one of them. So %0 to x, that does just what I want. So now even things that are like 0, 0 or 0, 1 or 0, 2, that's going to be 2 characters. Next, I'll remove the new lines, and now, because they're all 2 characters, doesn't get mixed up, I can now take all of that. This is the bytes of the file, of the audio file, and I'll pipe that into XXD, P for plain and R for reverse. And here's the file. It's not printable, of course. I'll pipe that into a file called audio. Let's use the file utility to check which kind of file that is. That is MPEG-3. That's basically MP3, an MP3 file. I can play that using MPV. So here it is.
に間に合いませんでした。
So there it is. And so yeah, here it is. MP3 file. MPV tells me which codec that is. MP3. You can also play that on the command line, MPV audio. It gives me this warning though. That is because the metadata is not complete. It's missing the duration. That's why MPV resorted to estimating it. And at least from my experience, this is leading to the file not being playable in all programs. So to fix that, I'll also use FFmpeg to fix it up. So I'll convert this audio file into, let's name that audio.opus. So I'll not only re-encode that, I'll also change the codec from MP3 to opus. It's a little bit more efficient, so libopus. I'll be able to get away with reducing the bitrate from 32 kbps right here to 24. This way it doesn't lose on quality, really, but the file size will get smaller. So now when I play this file, mpv audio.opus, it doesn't give me this warning like it gave me here. And also the file size got a little bit smaller, so the original was 10 kilobytes, this one is only 7 kilobytes. That's a little bit better. And I can now stitch those together into a single pipeline. So let's copy that. And let's copy the ffmpeg command I have here. And the last thing to figure out is the request. It contains the sentence that I started with. The sentence is this right here, and it got turned into this % encoding. I have a little executable here, URL in code, which takes in a sentence, or really any text like hello world, and it gives me the URL encoded form. So it doesn't have the spaces or any non-ASCII characters. It encodes them using this %sign encoding. And I can use that for example, this Japanese sentence. So every character here got turned into 3 UDF-8 bytes. So that's Unicode turned into this form. It's quite long. And it's exactly the same form as you see right here. So I can start making the script. Let's cd into desktop, touch scripts.sh, chmod +x to make it executable. And I'll open that in VS Code. So first of all, let's echo the first parameter like that. So run script, and let's make that provided sentence is that. So now I can run the script with the sentence like so. So here it is. It's accessible to the script now. And let's save that as a variable. So sentence equals $1. So that's the first argument, sentence. There we go. It works. Next up, I will use this program, URL encode, which, by the way, I've made that myself. Let's look at it real quick. So I have it stored in user local bin. And the code for it is pretty simple. It uses Node.js to convert into URI encoded into a URI encoded string this standard input. So it's really simple, just one line of code. It just simplifies, so I have to just enter URL encode. Let's do that. Echo the sentence into URL encode. So that is going to become my my URL encoded version. So encoded is that. Let's also echo out the encoded form. Let's run that. Okay, that works. Next, I take this encoded form and so I've replaced this sentence part with my variable, which is the $sentence. Actually, $sign encoded. And also, I need to get rid of the single quotes and replace them with double quotes. So it gets interpreted as a variable in Bash. Let's take this and place that into my script. So here, curl lingva this URL with my sentence encoded and compressed. And let's also pipe that to standard out and pipe that into JQ. So I'm going to pipe that directly into JQ. Get the page props audio query, pipe that into TR, pipe that into grep, pipe that into the while loop. That converts decimal to hexadecimal, and then convert hexadecimal into plain bytes. And then pipe that into ffmpeg. Need the backslash here. ffmpeg I from standard input to the file name, and the file name, let's name that sentence underscore sentence.opus. Let's now try running that script.sh. I run that, and there I have a file on the desktop. So that's the file that was downloaded using that script.
バスに間に合
And sure enough, that is the actual audio for the sentence that I provided to the script right here. Let's also clean up the outputs. ffmpeg gives me a lot of the output that I don't really need, so I'll get rid of that using that little bit of code right here. Let's rerun the script now. Now it just has the output of curl. Well, let's also get rid of the curl output as well. So here I'll use the, I think it's the kf actually. Let's check the curl silent. Okay, that's the -s. Now it doesn't have any output. Let's also make it output a little message. So successfully downloaded sentence. All right. Now it gives me this message. So there we go. The script is done. Let me clean up the files. RM audio, response, sentence. Okay, there we go. The script is done. Now the best thing about shell scripting is that once you're done with that, you can have 1,000 sentences and you can easily extract the audio for all of them with just a little while loop in Bash. So let me do just that. I have the file sentences.txt, which has those sentences here. So I'll pipe this output of cat into a while loop, while read sentence, do echo sentence, just to show that it works. There we go. There's the list of sentences. Now, instead of just echoing out the sentences, I will invoke the script on each one of those sentences. Script.sh on the sentence. And now let's run that. There we go. All of the files, all of the sentences just got downloaded, and it was so easy. I just had them all in a file. I wrote this little one-liner with a while loop, and that invokes a script, and I have sentences. And I could have had literally 1,000 sentences. I could have just left it downloading, and when doing something else, and when I would come back, they would all be there. And that is so amazing about shell scripting. You can have a utility that does anything, and you can easily automate that with those pipelines. So let's go back to the script briefly. So it does so many different things. Curl, it encodes the thing, it encodes the sentence into this URL encoded form, extracts the JSON field, converts the numbers into bytes, then re-encodes the bytes as the audio file into Opus, and then saves them, and then I have the audio files, and I can use all of them in Anki in my flashcards. I can just include them right here. So all of the cards that I have here, they have the audio that I got just this way.
友人に車で家まで
So that is really amazing. I will probably make more videos about other things that you can really conveniently do using shell scripting and different utilities you find on Linux in general. If you have watched this video this far and you're at all interested in that, please let me know that you exist, because I have no idea if at all anybody will watch that. So if you're interested, you can give me any ideas or just acknowledge that you exist and I should make those videos. I'm not just making them into the void. So thank you for watching, and I'll see you in the next one.